In this problem, we are told that the past sales records for a swimming pool manufacturer indicate that the total number of swimming pools in thousands, called capital N, sold during a year is given by N of T equals T times the square root of 4 plus T, where T is the number of months since the beginning of the year. So T must range between 0 and 12 months in a year, and they're asking us to find specifically N of 5 and N prime, the derivative of N at 5, and then we're to interpret these results. Alright, so to begin with, let's go ahead and calculate N of 5. N of 5, just following the rule, would be 5 times the square root of 4 plus the value 5, which is 5 times the square root of 9, which is 5 times 3, which is 15. And then we're to interpret the value. Again, N is in thousands, so this means 15,000 swimming pools have been sold during the first 5 months. So that's presumably January through May. They've sold 15,000 pools. They then ask us to calculate the derivative at 5. I'll find the derivative everywhere using the appropriate rules. Now, to do this, I'm going to reinterpret what N is defined to be just by using fractional exponents. I notice, first of all, when I'm doing this, that there's a multiplication in the middle of this. So there's going to be a product rule going on, and a 4 plus t's exponent would be 1/2. Square root is 1/2 exponent. So I'm going to begin with a product rule on the derivative and involve a chain rule on this second piece. So the derivative here, again beginning with the product rule, is the derivative of the first, which is the derivative of t, would be 1, leaving the second alone, plus the first, which is t, times the derivative of the second. And this is going to be a chain rule. Chain rule on 4 plus t to the 1/2. I'll bring the exponent down, leave what's inside alone, reduce the exponent by 1. 1 less than 1/2 is negative 1/2. And then to finish the chain rule, I need to multiply by the derivative of the inside. Derivative of 4 plus t is 1, and so I'm done. That is the derivative of every value of t. Slopes of the tangent lines would be the interpretation on the graph. What we're asked to find is n prime at 5. Now I could do some algebra to clean up this value, but since I only want the value at one point, the value of the function's derivative at one point, I think I'll just go ahead and calculate the value. As I walk through this, I see I need 4 plus 5 to the 1/2 plus 5, that's the value of t, times a 1/2. This negative 1/2 exponent on this quantity means that it's in the denominator, and it's a square root of the quantity, 4 plus 5 in this case. So now to find this value, I'll simplify. This is a 9 to the 1/2, which is 3, plus 5 times 1/2 times 1 over the square root of 9, which would be 1/3. So in all, this is the quantity. Let's see, these are sixths. I've got 5 sixths, and 18 sixths would be 23 sixths. All right. Now the interpretation of this, again, is the rate of change of the number of pools being sold in thousands per month. So this would be thousands of pools sold per month. That's the units on this. And again, the interpretation of this is that the sales are increasing by 23